Start recording now. Yeah, it's okay. I start recording now. So it's good for you to have recording. Okay, we start from here. No? I think if you remember last week, we were talking about organic compounds. In organic compounds, the first thing we talked about it was hydrocarbon, HCs, hydrocarbon. We call hydrocarbon HCs. H for hydrogen and C for carbon, and the name is hydrocarbon. Hydrocarbons actually this is the main component or the major branch of organic compounds. Organic compounds are those compounds in which the carbon is the main core. It is made up of carbon. The carbon is must in them, okay? So that's why the hydrocarbon are those compounds in which we have hydrogen with carbon must. Okay, so these are hydrocarbon. And hydrocarbon in your actually in syllabus or in your course, the most of the organic compound we will talk about they are hydrocarbons. Okay, in hydrocarbon we have categories. Suppose if we say this is a hydrocarbon this is a major group of compounds. We have categories. Okay, like we have 4 categories. We have alkanes. We have alkenes. I think alkanes we already finished it. Alkane we finish it. Alkenes today we will talk about alkenes, and then the third one is alkyne, and the last one is we call aromatic hydrocarbon. Aromatic hydrocarbon. So we already finished alkane. Now today we will talk about alkene, and alkyne will be following us. Alkane is the major portion. Alkene, alkyne, they are less. Means the topics are less. We can only go for the nomenclature. That's it. Okay. Now, what are alkanes? Here we should in the table. How we can differentiate between alkane, alkyne, aromatic are different. Okay. So these 3 are main chain carbon. So we have alkanes. The general formula is CnH2n. If you remember last time, I write +2. So if carbon is 1, so hydrogen should be how much? 2 into 1 plus 2. It will be this number of hydrogen. It will be equal to CH4. If carbon are 2, suppose we talk about carbon is equal to 2, or carbon is equal to 3, or carbon is equal to 4. If suppose we use the same formula for this one, C2, it should be how much? 2 multiplied by 2 plus 2. It will be equal to 4 plus 2, 6. So carbon will be 2 and hydrogen will be 6. If we have carbon 3, so hydrogen should be 8. If we have carbon 4, hydrogen should be how much? 10. You know, frankly speaking, if you look at all these compounds, suppose CH4, and then CH4 is okay, and C2H6, C3H8, and C4H10. Usually the carbon number, if you multiply with 2, the hydrogen will be 2 extra. Look at this. Suppose we have 2 carbon here. Hydrogen should be 2 multiplied by 2, 4 plus 2, 6. Here 3 multiplied by 2, 6 plus 2, 8. Here C4, 4 multiplied by 2, 8 plus 2, 10, like this. That's why we have this general formula for alkane, CnH2n plus 2. H2n plus 2 means this is the H number. Okay. For alkenes, that is a bit different. It is CnH2n only, not plus 2. It means if carbon number are 5, how much hydrogen we would have? How much hydrogen will be there?
10.
10, of course. Means only the double. 5 times 2, 10. If carbon we have suppose 7, hydrogen should be how much? Only
14.
double. 14. Yeah. If we have 10, so how much hydrogen should be there? 20. Okay. And then the alkynes are a little bit different. The same, the general formula CnH2n is there, but here we will write -2. It means that the number of hydrogen is 2 less than double. 2 less than double. Look at this. Suppose we have 5 carbon. C5. How much hydrogen should we have? 5 times 2, 10 minus 2, 8. Suppose we have carbon. So if you use this formula, so how much hydrogen we should have? First make the double. 7 times 2, 14. But 2 less. 2 less means 14 minus 2, it will be 12, like this. Or if you go for C9, so hydrogen should be, what is the double of 9? 18. 18 minus 2, 60. Is it clear now? So these are actually, if the formula is given to you, and then you have been asked whether that is alkane, alkene, or alkyne, you will use the general formula, this formula. This formula for alkane, for alkene, it is like this, and for alkyne, it is like this. You can differentiate from the formula. This is alkane, alkene, or alkyne. Correct? Any question? You have any doubt, any question, anything you did not understand?
No, thank you.
I mean, this is the general formula. You just use the formula. CnH2n plus 2 alkane, CnH2n for alkene, and for alkyne, CnH2n minus 2. No, the question is why it happens. We will talk about right now. We will talk about right now why the formula for alkene is CnH2n. Why the alkyne is CnH2n minus 2, like this. But why is different thing. But at least you should know what is the general formula. If the formula is given to you, the structure is not again. Usually, if we say, suppose if we go to the next slide, we say alkane. If the structure is given, it's very easy to find alkane, alkene, and alkyne. First is the formula. And the second thing is structure. Structure. Structure means the structural formula. So there are two things you can distinguish between alkane, alkene, or alkyne. If the formula is like this, suppose we talk about C2H6. Okay, C2H6 means carbon is 2 and hydrogen. Forget about this. Suppose this formula is given to you, you want to know whether this is alkane, alkene, or alkyne. You do calculation in your mind like this. Okay, let's see. We have calculation. Yeah, let's see. Okay, carbon, take carbon, hydrogen, don't take hydrogen. Hydrogen you calculate by yourself with carbon. If it is alkane, it should be 2 multiplied by 2 plus 2. So it is 2 multiplied by 2, 4 plus 2, 6. Okay, this is the same. It means this is alkane. Is it? Alkane. Don't go for the hydrogen number, carbon number. Take the carbon number, use your formula, and then see whether it go for the formula for alkane or not. If suppose we have this one, C2H4. Now, what is your formula for alkene? It is CnH2n. Okay, now we start from, we will suppose this is our example, C2H4. And then if somebody asks me, this is alkane, is it correct or wrong? So I want to know, okay, alkane formula is CnH2n plus 2. Now, what is this? C2, 2 carbon. So if we have 2 carbon for alkane, we should have 6 hydrogen. But here is 4 hydrogen. It means this is not alkane. What about alkene? CnH2n. So if carbon are 2, hydrogen should be double, 4. That's okay. C2H4, it means C2H2n, which is equal to 4. This is alkene. Okay. For alkyne, CnH2n minus 2. Okay, now suppose the structure is given to me. What is this structure? We say CH3, CH3, CH2. And then they ask me which compound is this? Categorize it, whether it is alkane, whether it is alkene or alkyne. So no need to go for the formula now. go for the bonding. Look at this, carbon-carbon bonding. Here carbon-carbon single bond, here carbon-carbon single bond. So all carbon, they have attached to other carbon with single bond. So no need to go for the formula. This is simple alkane. Because alkanes, they have all carbon-carbon single bonds. What about alkene? CH3, CH, CH2. Now, don't look for the formula. Look for the bond. You have a double bond here. You have a double bond here. If you have at least one double bond, here it's double bond. It is a single bond, no problem. Single would be there. But if I find even a single double bond, or one double bond here, so we have, so this is called alkene. No need to go for the formula. From the structure, it's easy. And then for alkyne, if we have a triple bond, suppose we have CH3 here. Wait, let me finish and then CH. Yes. Now we have how many carbon? 4 carbon, I think. 1, 2, 3, 4, 5 carbon. Okay. And then all these have single bond, but one of them is a triple bond. Carbon-carbon triple. Whenever you have a carbon-carbon triple bond, the whole compound will be alkyne. Now I'm using the formula. Is it same to the formula? It's aligned with the formula. Let's see. How many carbon we have? 5. 5 carbon. How many hydrogen we have? 3 plus 2, 5, plus 2, 7, and plus 1, 8. Let's see. C5H8. Using this formula, CnH2n minus 2. So how many carbon we have? 5. Hydrogen how much? Double. 2n means 10. 10 minus 2, 8. Same or not? But if the structure is given, I recommend you don't go to the number of carbon, hydrogen. Just check whether it is a triple bond. Yes. If it is a triple bond, it is alkyne. If it is a double bond, it is alkene. If it is a single bond, carbon-carbon single bond, it means this is alkene. Yes, now question. Somebody asked some question.
You answered, teacher. Thank you.
Okay. So means this is the way you differentiate between alkane, alkenes, and alkynes. Alkane CnH2n plus 2, the general formula, and then you will find our carbon-carbon single bonds. In alkenes, you may have 10 single bonds, but if you find the 11th one is a double bond, it means the whole compound will be alkene. You cannot say, teacher, 10 are single bond, it means this is half of them is alkane, half of them is alkene. No, there's no half of. Either it should be alkane or alkene. If you find we have suppose 50 bonds, 50 carbon and 50 bonds, one of them is double bond, it means the whole compound will be alkene, not alkane. The whole compound will be alkene. If you have 10 bonds and one of the bond actually it's a triple bond, it means there is no more alkane, it is alkyne then. Understand now?
Yes, teacher.
Okay, now we go for the alkane nomenclature. I think we have done it, but if you want it, we can repeat this alkane nomenclature as well. Nomenclature means giving name. Should we start from alkanes? Or we go for the alkene alkyne directly? Okay, we will start from alkane. Alkane take actually a longer time. Alkene alkyne is easy. Let's go for alkane, no problem. So alkanes. Alkanes nomenclature. Nomenclature actually giving name to the compound. Nomenclature. Nomenclature means giving name to the compound. Suppose if we have C5H12, what is the name of this compound? If we say, oh no, this is pentane, the name is pentane actually. And then next question, why it is pentane? We have to answer these questions here. Okay, for nomenclature, we have certain rules, and these rules were made by IUPAC. We call IUPAC. Okay, so these IUPAC actually made some rules. And this, for this one, we should know the counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Usually we stop to 10. If we have one carbon, the IUPAC give, we call actually the names could be of different names. You know, if suppose my name is Abdul Majid Khan. Abdul Majid Khan. It means I have certain parts of my name. This is my last name. We call it a family name. And you all have family names, means your grandfather or your family name. Okay. So alkanes, alkene, alkyne, they have a family name. Okay. But before family name, we have certain name. This is my first name, or you can say this is my actual name. Okay. So if this is my actual name, so for all alkane, alkene, alkyne, so we have, suppose we call it base name, and then we call it suffix, and then we call it prefix. If you studied English, prefix, suffix, you should know it. This is the actual name. Suffix, usually we call it, this is surname, like last name, like family name, okay? Suffix, it's maybe alkane suffix. For alkane, all compounds, they have same suffix because they belong to same family. Base name could be different, and prefix means, we will talk about it later on. But before this, we should come to the counting. If we have one carbon in the base name, we will add meth, M-E-T-H, meth. And then if we have two carbon chain, suppose that full compound is made up of two carbon, so the name should have a base, which is 2. It means 2. Meth means M-E-T-H, meth means 1. It means 2. C3 means if we have 3 carbon, the base name should have P-R-O-P, we call prop. And then if we have 4, so it will have B-U-T, but. Okay. And then if we have 5 carbon compound, the base name should have P-A-N-T. Now if you remember, here we have 5 carbon. That's why the name is pent. Look, why it's pent? Because of 5 carbon. This pent shows my compound has 5 carbons. Okay. So now if we have 6, so we'll say H-E-X, hex, hexane or hexagonal, or these hex means 6. Okay. 7 means hept. 8 means oct. 9 means non. And then C10 means deca or dis, D-E-C, dic. Okay. Decane or like deca, decadron or deca, suppose like this. Okay. So we must memorize these one, then we go for the nomenclature. If you did not memorize this one, we will be in trouble because we don't know. Suppose if we have compound C3, H8, we look at the carbon, and this is alkane. Why? Because the formula is of alkane. Okay, good. For alkane, what is the suffix? The suffix for all alkane is A and E. If I can make it in a different color, A, N, E, N, or N. Okay. Base depends upon carbon. Suppose for alkane, this is alkane C3H8. How many carbon we have? 3. For 3, I will come here. It is prop. So what should I do? In the base, I should write prop. Prop. And then I combine it, propane. The name is propane. It's easy, is it? Why propane? Because the N is the suffix, is the last name for all alkane, and prop for 3 carbon. So this is 3 carbon alkane, we call it propane. Now what about this prefix? Sometimes we have prefixes, sometimes we don't have prefixes. In this case, we don't have prefix, but we will use prefix. But before going to the prefix, suppose we have C6H14. First of all, is this alkane, alkene, alkyne? If it is more than double, 2 more than double, C6 means 6 times 2, 12, plus 2, 14. It's okay, this alkane. How many carbon do we have for alkane? The common name, you know, the suffix is A and E. How many carbon do we have? 6. Come here. Higgs. So the name should be, you combine, you don't write separately, you write in one place, we call hexane. Clear or not?
That's clear, teacher.
Yeah. Any question? Anything you did not understand here?
Yeah, yes, teacher.
Yes, please.
Does the lecture is recorded?
Yeah, yes, being recorded.
Can you share the link after you finish?
It will be there. You can come to your section because the lecture is in your section. You can go to the virtual class and then you will find the recording there, inshallah.
Okay.
Maybe after 10 minutes, 15, it takes 15 to 20 minutes to load when it's been finished. Okay.
Okay.
Okay, now we go for the prefix because we did not talk about prefix here. Before going to the prefix, we should go to the next slide. Let's see. Because if suppose you have CH4, C2H6, we have C3H8, these are the C4H10, C5H12. These are the first 5 members of alkane. One carbon, what was the base name for one carbon? Meth. 2 carbon, eth. 3 carbon, prop. 4 carbon, bute. 5 carbon, pent. Now, because these are all alkane, so we should add the suffix, which is the last name of all alkane. It is methane. Look at this. Ethane, propane, butane, pentane. Is it okay? This same principle applies to all the compounds. Any doubt here? Okay, now we go for the prefixes actually. Prefix usually come from branches. Because so far we talk about only the straight compounds, like this one. So far we talk about, suppose we have C, 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 and C. How many carbon we usually now, whenever we draw the structure actually, you should be careful about this one. Carbon will complete 4 bonds. Carbon will complete how many bonds? 4 bonds. If this compound is alkane, all carbon will be attached with single bond. Now, if you look at this carbon, how many bonds it made? Only 1 on the right side. Here. This carbon, only 1 bond here. If you go for this carbon, it is being attached to 2 bonds, like one from right side, one from left side. This carbon, 2 bonds, one right, one left. What about this one? We call terminal carbons. The first and the last are the first and the last. You can make this first, this last, or you can make this first, this last. Okay, we call them terminal carbons. We call them which carbons? Terminal. Terminal means last, which is at the end. There's nothing there. It means the last house of the street is a terminal one. After that, there's no more houses, suppose. Okay, so we call them terminal. Okay, but before terminal, forget about the terminal. How many electrons, how many hydrogen it needs? Because this is a hydrocarbon, 1 bond is here. This is single bond. We made it actually a little bit double. It looked double. Let me erase it. Okay, this is single bond. So means carbon will complete 4 bonds. We need 3 more bonds. From where do we make 3 more bonds? Hydrogen is there. So how many hydrogen we need? 3. Write 3 here. For this carbon, 2 bonds are there, 1 here and 1 here. We need only 2 hydrogen. You write here CH2. That's why we write CH3, CH2, CH2. Here, 2 bonds are there. We need 2 more hydrogen to make it 4. Here, for this terminal carbon, we need 3 hydrogen. Why? Because only 1 bond is there. If you want to make the formula, you have C4, or add C4 here, hydrogen at 3 plus 2, 5 plus 2, 7 plus 3, 10. The same formula will be C4H10. Yeah, this one. But this is the structure here. But if you look at this compound, this is a straight chain. Straight chain. Okay. Now we have another compound, suppose C5. How can we make the formula? First of all, we should write the carbon number, make it a single bond, and then 3 hydrogen here, 2 hydrogen here, 2 hydrogen here, and 2 hydrogen here, and 3 hydrogen here. So if we count the number of hydrogen carbon are 5, and hydrogen should be 12. That's it. Again, it is a straight chain. So it means there's no branches. Where there's no branches, there's no prefix. There's no prefix. Prefix will come when the branch comes out. So now we are going to make a branch. So branch is actually, suppose, which thing we can make branch? Let's see. Okay, yeah, here. We have methane here. And we have ethane. So far, we will study about these two branches, either methane or ethane. Ethane formula is C2H6. It is C2H6. And methane formula is how much? C4CH4. If I remove one hydrogen from this one, minus hydrogen, I remove one hydrogen, what should be the formula now?
CH3.
CH3, good. It will be CH3. But now the problem is carbon making 3 bonds here. So carbon will make one more bond. That's why we write like this. We don't know what is this, what is here, but it will make CH3. What is the name of this compound? Because it is one carbon alkane, it is called methane. Here, look at this. This is the same one. And what about this one? C2H6? Ethane. Ethane. If you remove one hydrogen from it, what will become? It becomes C2H5. Is it? No, this is C2. Don't look at the hydrogen, look at the carbon. All the names, hydrogen is nothing. Hydrogen is, don't look at the hydrogen. Hydrogen only to know whether it is alkane, alkene, alkyne. When you are naming it, look for the number of carbons. How many carbon we have here?
Yeah, I'm sorry.
2. It's ethane. But ethane, 2 carbon, C2H5, if we remove one hydrogen, it will make any other bond like this. So this was methane. When you remove one hydrogen, it will become, we call it, this is methyl. What we call it? Methyl. So methane goes to methyl if you remove one hydrogen from it. And ethane will go to, what should be the name? C2H5?
Ethyl.
Ethyl, yes. So these will come as a branches now. You will see CH3 is a branch or C2H5 is a branch. Whenever you see CH3 is a branch, you will write methyl and it will go to the prefix. If you find C2H5 is a branch, you will say ethyl before the name. Okay, let's go ahead. When we have examples, we will understand many things. Let's see. Okay, now we have a compound. Suppose it is a compound CH3, CH2, CH2, CH3. How many carbon we have? It is a straight chain, no branch. How many carbon we have? 4. We should name them. 1, 2, 3, 4. So 4 carbon is bute. Because all are single bonds, so it is alkane. So the name is butane. Good. Is it okay?
Yes.
Now we have another compound, but the formula is how much? C4H10.
H10.
Now we have another compound like this, CH3, CH, CH3, CH3. This is not a straight chain now. Why? Because if I go through this way, where is the branch? Here. Here is a branch. This methyl does not come in the plane. It is going out of the plane. It is going out of the straight line. So this is my main chain we call straight chain. How many carbon we have in straight chain? 3 carbon.
3.
And this is actually just before 2 minutes, we say this is methyl group if it comes as a branch. This is not methyl. This is a part of the compound. This is part of the straight chain. This methyl, which comes as a branch, we call it methyl group. So how many carbon? Forget about this one. For CH3 right now. You look at this straight chain, the one we circle. How many carbon we have in the circle? 3. 3 carbon. For 3 carbon, what is our naming procedure? For 3 carbon, we use prop. Is it? Because it is carbon-carbon single bond, so the name should be propane. Now we come to the branch. What is the name of the branch? Because it is methyl, methane to methyl, so we write it methyl propane. This is a prefix. This is the main, look at this. This is a base. This is a suffix. Suffix, I will write S for suffix. This is the base we call the main name. And this is a prefix, I will write P. Whenever there is a branch, the prefix will come into effect. If there is no branch, no need for the prefix. You got it now? So the name is, what is the formula for this compound? Can you count the number of hydrogen carbon?
Yes.
How many carbon we have in this whole compound, not in the, the whole, this whole compound. This is the whole compound. 4 carbon, and how many hydrogen we have? Can you count them? Three plus 3 plus 3, 9 plus
Yes,
1, 10. Now look at this. We have a different name for different look at this. Methyl propane and butane. They have same formula. But if you look at the structure, this is different because of the name. Look at this. The formula is same, but they have different name because of the different structure. We call them what? Isomers. Isomers are those compounds which have same molecular formula. I will write FF, but different structures. Different structure formula or even structure, you can say. When the structure is different, the IUPAC name will be different. Look at the IUPAC name depends upon the structure. Look, this is butane and this is methyl propane. But now the question, another question comes sometimes. Okay, I will give you one more example. We go for a higher carbon. Suppose we have a structure like C, 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 and C. And then I will make 1, 2, 3, 4, 5. Now, how many carbon we have here? 6. How many carbon we have here?
5.
But I will make 1 C here. How many carbon now?
6.
And then another one. How many carbon we have now? 6 again.
6.
Okay, and now I will make another one. Okay, sorry. No. This is a different one. Okay, let me draw a line. How many carbon we have in this one? 6 again. And then if I do like this, how many carbon we have again?
6.
6. Good. So it means all these structures, they have 6. Why did I only draw carbon? Because the main thing in structures is carbon. Carbon is the skeleton, like bones. Okay, you want to make something, first of all you make a skeleton. Carbon is the skeleton, and then hydrogen is only two. It's a kind of thing, it's not too much important for us in the structures. Hydrogen is only to make 4 bonds, that's it. Now we want to make hydrogen here with the green one or the blue one. How many hydrogen we need here? 3. How many hydrogen we need here? 2. How many hydrogen we need here? 2. We can write on any side. How? 2. How many? 2. How many? 3. So how many hydrogen are total? 3 plus 2, 5 plus 2, 7
14.
to 9, 14. It is exactly the same formula as C6, 12 plus 2, 14. This is, the name is called hexane. 6, because it is alkane, the name is hexane. Good. Now here, how many hydrogen we need? 3. How many hydrogen we need here? 2. How many here? 2. What about this one?
One
For this
hydrogen.
carbon, only 1 hydrogen. Why? Because it already made 3 bonds. Here, 3. And what about this carbon? 3. This carbon also 3. Okay. So again, if you count the number, it will be same.
Teacher, all of them hydrogen equal 14.
Yeah, all of them, they are equal to 14. So it means hydrogen does not make any difference. Hydrogen will be same. Here 1, here 2, here 3, and here 3 as well. Let's see, because this is a nomenclature of alkane. CH2 here. For this carbon, no need for any hydrogen because it already completed this. So 3 here, 3 here, and 3 here. Here, 3 here, 1 here, 1 here, and 3 here. And 3 here, and 3 here. All of them, they have the same formula. Okay, I will erase these one. So they have the same formula, but the name should be completely different. I want to erase this one because they have the same formula. Okay, so C4, now C6H14, this is the formula for this one. So here, now we start from the beginning. We start from the beginning. Let's let me select this one. So let's see. Select the longest chain of carbon, straight chain. You will circle like this. Do you find anything outside this chain? Outside this, you know, the straight chain?
No.
No. So it means this is straight alkane, straight chain alkane. We call it straight chain alkane. So the name should be only hexane. There will be no prefix. Why? Because the prefix will come when the branch comes here. Here, now you have 1 carbon outside, means 1 CH3. Here, 1 outside. Here, 2 outside, is it? Here, 2 outside. But if you look at these 2 structures, what is the difference between these 2? How many carbon in straight chain? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So means we can write pentane here. We will write prefix right now, but I will keep space for this one and then space for this one as well. This will be pentane as well. Because our main concern is the one we circled already. We call it select the longest chain of carbon, longest and straight chain. You circle it, okay? So this is pentane, and this is, what is the branch here? The branch is CH3. Here is also CH3, is it? So what we call CH3?
Methane.
Methyl, not methane. When it is CH3 as a branch, it will be methyl.
Oh yeah, if
Methane will be,
SH4, methane.
yeah. CH4 is methane, CH3 is methyl group if it is a branch. This CH3 is not methane, this is part of your compound. You cannot see methane, this is part of it, okay? If it comes out as a branch, then you can call it methyl. Here also, what about this one? It's also CH3, same. So it means methylpentane, good. But if we look at the structure, there is something different. What is the different thing here? In this structure, in these two structures. Where is the methyl group? If you look at this methyl group, it comes, it is near to the terminal carbon. It is in the second carbon. It is here.
Yes.
Let's see. Here, this carbon, after this carbon, the second carbon we have methyl. Here, the third carbon we have methyl group. Here, if we can say 1, 2, 3, 4. But you will always, the IUPAC rule says you should always start counting from that side where the branch comes nearer. If we follow the IUPAC rules, we should start counting from this side. Okay, let's see, counting, start counting. Let's start counting now. Okay, let's 1, carbon, 2, 3, 4. Only the one you circle, the straight chain, you should count this one. So 5. Where is the methyl group here? On carbon number 2. Here, if you look at this one, if you start, the IUPAC rule says you start from that side where the branch means the CH3 comes nearer. 1, 2, 3. We start from the other side. 1, 2, 3. Means same. If we count from any side, it will become same. So I can start counting from either side, from right side or left side. It is the same thing. Let's see. Now we have 1, 2, 3, 4, 5. Now, where is the position of branch here? The methyl group is attached to which carbon? Carbon number 2. Here, carbon number 3. So you will write 2-methylpentane and 3-methylpentane. Yes, please.
Teacher, we can't see the screen.
Oh, sorry. Why it is happening? Let's see something happen in the internet. I think. No, internet is okay. Okay, what is the problem? Now it's okay?
Share screen and yeah, now it's good.
Okay. So, did you see it before? Or how much time?
No, teacher, repeat it.
From where?
When we start from which side? The nearest.
Okay, yeah. Yeah, this one. Look at this. The IUPAC rules, we have rules. We say the rule says you should start counting from that side where the branch comes nearer. We have two structures, this structure and this structure. We start counting, we know it already. 1, 2, 3, 4, 5. We cannot say 1, 2, 3, 4. Why? Because the branch here is, it will be on carbon number 4. This is number 4 carbon if we start from this side. That's why we have only one option. We should start from this side, from the right side. If you start from the right side, this is carbon number 1, this is carbon number 2, 3, 4, 5. Good. Now we go to this structure. The third structure. Now here we can start from either side, from left or right. Why? Because if you start from left side, right side, 1, 2, 3. The branch comes at carbon number 3 here. If we start from left side, 1, 2, 3 means it's up to me now. I'm free. I can start from any side. I started from right side. This is my choice. If you start from right side, it was carbon number 1, carbon number 2, carbon number 3, 4, 5. Now look at this. What is the difference between these two structures now? The position of methyl group. This is methylpentane. We know it. This is methylpentane. But here the methyl group is attached to carbon number 2. That's why we write 2-methylpentane. Here the methyl group is attached to carbon number 3. That's why we call it 3-methylpentane. You got it now?
Yes, teacher.
So we'll write 2-methylpentane, 3-methylpentane. Okay. Now we go for the structure number 4. 1, 2, 3, structure number 4, and structure number 5. If you look at this one, if I can take this one, suppose it will be too much writing in this page, but let's see. Let me erase something from here. Can I erase this one? Cannot erase, why? Oh, I saved it already. Okay, leave it. Okay, we have this one. Suppose this one, nice, sorry. Look at this position. We first carbon and last carbon. Suppose this is 5 carbon. 1, 2, 3, 4, 5. We cannot make branch here. It is impossible. We cannot make branch here. First carbon cannot make any branch. So we have 3 carbon. We can make branch here. We can make it here, or we can make it here. If you look at structure number 2, we made a branch here. Is it?
Yep.
If you look at the structure number 3, we made a branch here. And then the other side, we don't have a branch here actually. And this is carbon number 3. Structure number 3, this one, okay? If we want to make the, different structure, what I'm going to do, can I make a branch here? Yes, I can make a branch here. I will make a branch here, but we have to erase this one now. They look like different structure, is it? We don't have this structure. Or do we have? Do we have this structure here? No. We have this structure and this structure. The carbon, we should move it to this carbon, the methyl group. We don't have it here. But the question is, apply the IUPAC rules. What the IUPAC rule says? You start counting from that side where the branch comes near. Now you start from here. 1, 2, 3, 4, 5. So where is the branch? On carbon number 2. But we have already one structure with carbon number 2 branch. So it means this is the same structure. This is not a different structure. We just, you flip over. It's like, you flip over like this side, change the sides. You will have the same structure like this. You 180 degree, if you flip over 180 degree, you will have the same structure as structure 2. So it means this is not a new structure. This is the same structure. Okay, let's see. I don't want to make it complicated for you. Just erase this one, okay? That's why we go for 2 branches now. We go for 2 branches. Okay, let's go. Okay. Okay, that's it. Now we go for 2 branches. If we go for 2 branches, how many branches we have 2 here? We start counting from which side we can start counting? And number 4.
Right side.
Right side, of course. We cannot go from left side. It is wrong because the right side, the branches comes on carbon number 2. So I will write 1 here, 2 here, 3 here, 4 here. How many carbon we have in our straight chain? 4. So the name should be now not pentane, not hexane, or rather it will be butane. Okay, now we have branches. The branches are 2. One is methyl group, the other is also methyl group. So it means if they have 2 branches and they are the same, so we can use di. Di means 2, like di and tri. We use di and tri. So because they are same, so we can use dimethyl now. We can use what?
Dimethyl. Yeah.
Dimethyl. Why? Because there are 2 methyl group attached. Now, this is a prefix, but it's not completed yet because we don't want the position of them. This is 1, this is 2, or this is 1, this is 2. What are the position of this one? We talk about this one now. 2. What are the position of this one?
2. Also 2.
2. So we should not write 2 dimethyl. You should write 2, 2 dimethyl. Means one is on carbon number 2, the other is also on carbon number 2. So we should write 2 dimethyl butane. You should not write 2 dimethyl. Okay, teacher, because they are 2 in the same carbon, for each branch you should write the position. If it is 2 or 3, whatever it is, you should write. If it is suppose 3 in the same, you should write the same. Okay, now we go for the last one, and this should be our last one. We will go to alkene then. if you have time. So we go for the last one. How many carbon we have? 1,
4.
2, 3, 4. Did I write correctly? Yes. We can write from both sides because one carbon, the first will come on 2, the second will come on 3. If I start from here, 1, 2, 3, the same thing will be there. So the main name should be butane. Okay. We have 2-methyl as a branches, no problem. We should write dimethyl here. I will not think about it too much. Now we go to the position.
Position 2 and 3.
2 and 3, yeah. 2, 3 dash dimethylbutane. So what is the formula for this one? C6H14. What is the formula? C6H14. 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 So it means 1, 2, 3, 4, 5. We have 5 different structure, but the formula is same. So all these 5, we call them isomers. We call them isomers. But the name should be different. IUPAC name should be different. The formula will be same. So here in this topic, we learned isomers and we learn how to name alkanes. Is it clear now?
Yes, teacher.
Any question? Any doubt? Because we are going to alkene now. I want to finish alkene alkyne in 10 minutes, okay? But this alkane took a long time because we have to make our base. Clear? Let's go to the next slide now. Now we talk about alkene. Alkene,
Yes.
how would you know this alkene or not? There are two things, either from formula or from structure. From structure, if you find a double bond, carbon-carbon double bond, it will be alkene. If the formula, you have the, suppose C5H10. If the number of hydrogen are double than carbon, it means it is alkene, okay? Now we want to name alkene. Nomenclature of alkene. Nomenclature means naming. We use the same protocols as alkane, but the only thing in alkane, the suffix means the last name, the family name was ANE. Here it will be ENE. Only difference is this one, not ANE. If you remember, methane, propane, butane, hexane, heptane, octane. Here we will see ethene, methane, propene, butene, pentene, hexene, heptene, octene, like this. The other things will be same. Now here the most important thing here is the double bond. We should mention the position of double bond. Suppose we have 3 carbon and we have 4, suppose, and we have 4. Now, what is the name of this compound? First of all, we should make hydrogen. Hydrogen is very easy. You need 3 hydrogen here. How many? 1, 2, 3. We have bonds. We need only 1 hydrogen here. And here, how many? 3 or 2? What should I write here? 2, not 3, because it's already 2 bonds here. It should be 2. So what is the formula? C3. It should be how much? 2 plus 1, 3 plus 3, 6.
6.
Of
Yes.
course, it's alkene. Okay, so alkene means C3H6. So now, what is the name of this one? How many carbon we have? 3. For 3, we use prop. If
Propane.
you remember, prop. So usually for propene, we don't say 1 propene. We say propene. How well you can write 1 propene? Why 1? Because the double bond is between carbon number 1 and carbon number 2. You cannot say carbon number 2 and carbon number 3. When you have a double bond, you cannot start from this side, because the double bond comes from this side, comes nearer from the right side. Last time we said the branch comes nearer. Now in alkene, no branch priority. The priority will be given to the double bond. Now the double bond will rule the whole compound. If the double bond comes near from one side, we should start counting from that side. You got it? Okay, let's see. When we have example, we can. Now, what is this compound? 3 hydrogen, 2 hydrogen, 1 hydrogen, and 2 hydrogen. So C4H8. Of course, it is butene. Okay, we go for the next one. CH3. Here, because it is a double bond here, so we need only 1 hydrogen here. And this, for this carbon, we also need 1 hydrogen. Hydrogen we can write on any side, it doesn't matter. If I put hydrogen there or here, it doesn't matter, okay? And here we need 3. How many carbon we have? C4H8. So it is also butene. But now what is the difference between this butene and this butene?
This one a bute and the other is 2 bute.
Yeah, now this one is because from 4 carbon and onward, you must mention the position of double bond. We start from this side, 1, 2, 3, 4. Here we can start from either side, either from left or right, because the carbon, the double bond will start on from carbon number 2. Suppose we start from here, 1, 2, 3, and 4. Where is the position of double bond? Between 2 and 3. Here, between 1 and 2. If it is between 1 and 2, we will write the first number, not the second number, 1 butene. What about this one? If it is between 2 and 3, we will write the first number, 2 butene. This is simple. 1 butene and 2 butene. Clear?
Yes.
Now we go for the one more example, then we'll go jump for alkyne, okay? So let's see, we have a compound here, CH3, I will write like this, CH and CH3, CH2, C double bond, CH2, and CH. So now, this CH2. What is the formula? No need for the formula. You know, this is my, suppose this is my exam, I want to name this compound. What should be the name? Select the longest chain. Select the longest chain, first rule. But when you have alkene, you cannot, you know, you cannot remove this double. This double bond should be part of your, chain. This double bond. Suppose here is a double bond. Let's see. Here is a double bond. Yeah, this one. Now, counting from which side should we start? How many carbon? 1, 2, 3, 4, 5. C6.
Right.
Yeah. From right or left?
Right.
Why?
Right, because the double bond is most important.
Yeah. If you look at this compound, you know, the branch comes from left side, but the priority will be the double bond. The double bond comes from right side, so we don't care about the branch. We care about the double bond. So 1, 2, 3, 4, and 5. So means 5 carbon chain we have. The name should be pentene, is it? Pent for
Yes.
5 carbon, ene for this one. But where is the double bond position? Between 1 and 2. So I should write
But
1
one.
pentene, is it? 1 pentene, 1 dash pentene. That's good. Now, but we should not go for, you know, forget about the branch. Where is the branch? Carbon number 4. What is the name of this branch? CH3, it's methyl.
Methyl.
So we'll write methyl.
And 4, number 4.
But the number is 4, so we should write 4 dash methyl dash 1 pentene. Is it difficult?
No. Same.
No, it's not difficult, but it needs practice. Practice, nothing else. It's so easy. If you understood that alkane, it's easy for alkene and alkyne. Okay, now we go for alkyne. Alkyne is the same, exactly same, but only difference is it is a triple bond, and then the other thing is the suffix should be YNE, ine, not ene. Butane for alkane, butene for alkene, butine for alkyne. Suppose we have like this. So this is 3 carbon. We find a triple bond, so this should be alkyne, is it? We know it. But what is the formula? C3H4. From the formula, we can also know 3 times 2, 6. 6 minus 2, 4. That's okay. 4 is there. Means we want to find the number of hydrogen here. So the formula is, if you remember, we have CN H2N minus 2. If we have 3 carbon, we should have here 3 times 2, 6 minus 2, 6 minus 2, 4 it is there. C3H4, this alkyne. Good. Now what should be the name? Of course, it's 1, 2, 3. 1, 2, 3. So it means it should be propyne. 3 prop, YNE for alkyne, propyne. Got it? You can write 1 propyne as well, but usually for 3 carbon, we don't write it like this. But you can write 1 propyne or simple propyne. If we go for 4 carbon, then we suppose the double bond, triple bond could be here, and the triple bond could be here. Now this is 1 butane, and this is 2 butane. I did not mention the hydrogen as well as the number, because we know 1, 2, 3, 4. 1, 2, 3, 4. And what about this one? This is 3 butane or what?
No, 1.
1 but
So this is 1. That's why we don't write. This is the same structure. This is 1, not 3. So that's why we don't write it even. Okay. So this is 1 butane. We did not mention. You must write hydrogen here. Suppose this time I think there is no writing. Very less writing here means we will not draw any structure at least. The structure will be given. You should, write the name, or the structure will be given. You should match with the structure, the name. Okay, like
So
this.
there's only 1 hydrogen.
Yeah, this one is, sorry, not 3. Only 1 hydrogen. Okay, here no hydrogen. Here 2 hydrogen, and here 3 hydrogen. Okay, here 3 hydrogen. There's no hydrogen, and 3 hydrogen. C4H6. Got it?
Yes.
Is this difficult?
No, it's easy.
Now, we give one more example. When the double and triple bond comes together, so what would you do? Double and triple comes together.
you begin with that triple bond
No,
first or second.
look at this. Okay, we have examples. Suppose we will give examples. CH2, CH, CH2, CH3, CH2. Okay, wait a minute. Let me erase something from here. Okay. Suppose you have CH2 here, and then you have, here is this one. We have C triple bond here, C and CH3. Now, how many carbon we have? 1, 2, 3, 4, 5, 6. It means hex. 6 is hex. This is okay. Hex means 6 carbon. No branches there. Okay, good. So now we have, look at it, we have a triple bond as well as we have a double bond. This is not alkene, not alkyne. Okay. We cannot say this is alkene alkyne. This is together mixed to alkene alkyne. So we should mention both of them. Let's see. Which of the triple bond or double bond comes nearer? Double bond comes nearer or triple bond comes nearer? When you start counting. Double. So whenever we have a triple bond or double bond which comes near, you start from there. 1, 2, 3, 4, 5, 6. Good. Now we have hex, 6 carbon. So where is the position of double bond?
1.
You don't say hexene. You can say 1 hexene like this. 1 hexene. But dash, where is the triple bond? 4.
4.
You don't say hexane, 4-ine. You write 4-ine. 1 hexene, 4-ine. 1 hexene. The position of double bond is in 1 position, and dash 4-ine means the position of triple bond is in carbon number 4. or you can change it, which is easier. I like this way. I usually ask the student not to follow this one, follow the other one, like this. This is okay, correct. 1 hexene 4 ion. Or we can say the numbering you cannot change. This is the numbering. The name you can a little bit change. How many carbon we have? 6. Write hex. What is the position of double bond? 1. You write 1 ene. Ene means double bond. And then where is the ion? 4. 4 ion. Correct. Hex means 6 carbon. 1 ene means the position of double bond is in carbon number 1, and the position of 4 ion means the position of triple bond is in carbon number 4. Hex 1 ene 4 ion. Or you can use this one, 1 hexene 4 ion. This is same. Yes, please.
Hex dash 1. Then what? Then second dash or
ENE dash 4 dash ion. YNE ion.
Okay.
Ion for the triple bond, ene for the double bond. Now we have, suppose we have like this. This one. Okay, what is the, how many carbon we have in this structure? 1, 2, 3, 4, 5. Pent, right, pent. Now, from which side should I start? From left or right?
No, the left side.
Why? Because the triple bond comes near. But it will come near. I cannot say 1 ion directly here. The triple bond should be should be written at the end. So I will go for the ene. Where is the position of ene?
3.
3. So pent 3 ene. And where is the ion? 1 ion. Means ene should be first followed by ion. The position does not matter in the naming, okay? The numbering you should do it accordingly. Or you can say, if you want to like this, so it should be 3 pentene and dash 1 ion, like this. If you want like this, okay, like this, sorry, this one, like this, but it is okay. This is a rare case. When you have a double and triple bond together, it's not alkene, it's not alkyne, it is a mixed one, then you have to like this, ene and ion together. But you should not break the rules, IUPAC rules. Start counting from that side where the double or triple bond comes nearer. If the triple bond comes near, start from that side. If the double bond comes near, start from their side. But there is a very tricky situation. This is the last example, then we finish it. There is a tricky situation here. Suppose we have CH now what should I do? Because the double bond and triple bond comes, if we start from here,
up to me.
the double bond comes on 1 and the triple bond comes on 3. If I start from here, the triple bond comes on 1 and the double bond comes on 3. Suppose if I start 1, 2, 3, 4, here 1, 2, 3, 4. What should I do now?
The first one, teacher.
So now the priority will be given to double bond, not triple bond. The first one you give priority to triple bond. When you have everything similar, every single thing similar, you cannot decide. Then the IUPAC rule says you should start from that side where the double bond, if every single thing is similar, no difference is there, then you start from the double bond side, not from the, it means now this is wrong, this is correct. So what is the name now? But 1 ene and 3 ion. Is it okay? But this is a very rare case. Okay, it's the only case like this. Clear?
Yes,
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 teacher.
yes.
I think we have finished alkene, alkyne, alkane, all the things. So if you have any problem, anything you want to discuss regarding this one, because tomorrow, inshallah, we will start, I will send you now. Tomorrow we can start from, I think, the previous weeks, like week number 10, week number 9, we will talk about molarity, and then we will talk about the oxidation reduction. So these things, you join the class tomorrow as well. And then
Same
ask
time?
your students, yeah, same time, inshallah. And ask your
Inshallah.
friends, please join the class. It does not harm them, because this time is, I think, if you don't want to enjoy, this is the best time to be here for 1 hour, 1.5 hours. It's not too much time. So it is very useful for you, because
Yeah,
you're
it's
free
helpful,
now.
teacher, yeah.
So this is the kind of revision, the whole revision. It means this is the kind of good thing for the even exam, because all things, they will come into your mind. And the recording will be there. You can watch it later on. If you can send it to your friends, the links, it's there. Okay. Any question in these topics? Not in the previous topics. In the previous topics, we will talk about it tomorrow, inshallah. In these topics, alkane, alkene, alkyne, nomenclature, isomers, and then naming of the compounds, these things. If you have any questions, let
These
me know.
links, teacher, which slide?
This is yeah, these are in week number 12. I already sent it. Okay, these are in week
The
number
last
12.
week. Yeah.
Yeah, last week. This is the last week, because actually we did not cover alkene, alkyne. That's why I think I thought maybe it will be a kind
I'll
of
tell our section about
3.3.
that.
Yes, please.
I will tell our section, my section.
Yeah, please tell them that join the class. If they cannot join, at least the video will be there. They should watch the video. Okay, this is very helpful for you, because exam is coming, and I want all the students to be in good grades. Okay.
Okay, teacher, thank you.
Yeah, you're welcome. Any question, you can ask me any question. Tomorrow, inshallah, I will send on the Blackboard. You should just check the announcement. It will come to your email as well, which topic we will discuss tomorrow. And then sometime, you have something to do. If the topic is not of your interest, you can skip it. The recording will be there. But I encourage you to please come, and then, because here you can ask questions. In recording, you cannot ask any questions. Okay?
Okay, okay.
Thank you. Thank you.
Thank you very much for your time.
You're welcome.
I'm sorry today I get in late because I have
No,
to
it's okay.
study
It's all right.
tomorrow.
It's all right.
I
It's
have-
all right.
Okay, goodbye, teacher.
Okay. Okay. Goodbye.